Okay, so I've just got one more example to do here. And in this one, we're going to have a look at what happens with cumulative distributions. We might even get a chance to have a look at the graphs of some of them, so might actually end up taking another video after this. We'll just see what happens. So a professional archer has a 32% chance of shooting a bullseye. If they take 5 shots, find probably that x is greater than or equal to 1. And the probability that x is equal to 3, given that x is greater than or equal to 1. And as well, kind of specifying that x is equal to the number of bullseyes that are actually taken. So the part B there, for example, the probability of x equaling 3 given that x is greater than or equal to 1 means the probability of getting 3 bullseyes given that they shoot more than one bullseye. Or more than or one bullseye, I should say. So if we want to do the probability that x is greater than or equal to 1, there's a couple of ways we could do this. So we could do the probability that x equals 1 plus the probability that x equals 2 plus the probability that x equals 3 plus the probability that x equals 4 plus the probability that x equals 5. Now that's going to be an awful lot of calculation given that we have that rule for this. So, you know, I'm not particularly keen on doing it that way. We could also turn it around and say, well, that's like most of the probability distribution. Instead of that, we could just say, well, it's 1 minus the probability that we don't hit any bullseyes whatsoever. So I might just say that's equal to 1 minus probability of x equaling 0. Now that's probably a nicer way of doing this question because it only involves one calculation, and when we've got x equals 0, that's kind of nice as well. So I'm going to go with it that way. So that's 1 minus, now it's ncx, so n is the number of shots, which is 5, cx, which in this case is 0, multiplied by p, which is 0.32, to the power of x, which again is 0, multiplied by q, which is, well, the other probability, which would be 0.68, to the power of n minus x, which is 5 minus 0, which is just 5. So 5c0, well, that's just equal to 1. Anything c0 is just 1. And 0.32 to the power of 0 is also just 1. So that's gone as well. So what we're left with is just 1 minus 0.68 to the power of 5, which is actually a calculation that we can do fairly easily. So I'll just go equals, I'll bring up the calculator, and we've got 1 minus 0.68 to the power of 5. And we get 0.8546. So that's the answer. I'm just going to confirm that on the calculator. So I'm going to do this time a discrete, and it's going to be binomial CDF because we're looking for x being greater than or equal to 1. So it's taking on multiple values. So the lower value in this case is 1 because we want to be greater than or equal to 1. And the upper value is 5 because that was the highest number of trials we had. So the number of trials again is 5. And the possibility of getting the bullseye was 0.32. So once I type that in, just go OK. And there it is, the same answer. So just confirm that we've got that right. So not too much trouble there. Now I think that that's probably your best way to do it. So you either turn it around like this, or you can use the calculator. And, you know, keep in mind, I guess, that when you get a question like this where it's adding together heaps of different values, it's either something that you can turn around pretty nicely, or otherwise you're expected to use the calculator for it. Now, just in the last few seconds here, I would like to sort of show something else. So what I'm going to do is I'm going to go to the menu, and no, it's not going to let me. I'll just have to do it in the next video. Alright, we'll do that then.